Welcome. So we're going to continue our example of tossing a coin 3 times, where X is the number of heads in those 3 tosses. So previously we had a tree diagram to show the sample space, and now I've drawn the probability distribution of the random variable here graphically. So I'm just going to take a look at here the value of X. So previously we looked at the probability of getting 2 heads in 3 tosses of the coin. So that probability we found was 3/8, and we also wrote that in decimal. So I'm just going to put this at the top of the bar. So in decimal, that was 0.375. All right, so we could go back to the tree and find the other probabilities. I'm just going to put them here. The chances of getting no heads, that would be tail, tail, tail. So that's just 1 out of the 8 times. So we'll do 1 divided by 8 there, 0.125. And then the other values here, X is 1. That probability is also 3 out of 8, 0.375. And then finally, you could get 3 heads, head, 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 and that happened 1 out of 8 times. All right, and then we learned rather than doing the tree diagram, we could use our binomial PDF function, and I'm going to just write that right here. The probability of getting 2 heads, we did binomial PDF 3.5 and 2. So it was N, P, and this value we identify as K, X equals K. So the switch now is, what if we wanted to find, instead of the probability that X is exactly 2, what if we want to find the probability of getting 2 or fewer heads when you toss a coin 3 times? So on my graph down here, 2 or fewer would be 2 heads or 1 head or no heads. So I'd want to know those probabilities in total. So on the calculator, we would have to find the binomial PDF for X equals 0, X equals 1, X equals 2, and then add those 3 together. So that can be a little bit tedious, especially if we end up having a sequence of more terms that we have to add, but we could certainly do it that way. But we're going to learn here quicker way, but let's just do one more of these. So let's do the probability of getting no heads, so 0 heads. So I would go to my distributions, so second variable button, and then I usually just scroll, so binomial PDF, and then we would do N is 3, 0.5 of the probability of a head, a success, and then chances of 0 heads. And that's where that 0.125 comes from if I didn't have my answers over here. All right, and then we would also take the probability X is 1, so that's going to be 0.375, and then plus 0.375 for the last part, and then we'll just add those together. So 0.125 plus 0.375 plus 0.375, so 0.875 is the probability of getting 2 or fewer heads. All right, so let's learn how to do that a little bit more quickly here. So we have a function called binomial CDF. So rather than PDF, CDF. So this stands for cumulative probability. So what this function will do, I've listed all the possible values of X here when we toss the coin 3 times and count the heads. So I'm just going to circle for this question. We'd like to know the probability of 2 or fewer heads. So 2 or 1 or 0. So anytime we want to find a probability where X is less than or equal to some value K, so in our example, the probability that X is less than or equal to 2, this function that I'll abbreviate a little bit, Binomcdf, will take care of adding up those individual probabilities for you. So the key to it is that it is required, though, that you're always starting at 0 successes. So it starts at 0 successes, and then we'll keep adding sequentially until you get to that stopping value k. So Binomcdf. All right, so it's still n, p, k. So in this example, we tossed a coin 3 times, probability of a head 0.5, and we want to tell the calculator to add up all the probabilities starting at 0 heads and ending the addition when it gets to the 2. All right, so let's see if we can get that answer. So back to your distributions. And now go past Binomcdf to CDF. And then 3, 0.5, 2. And that gives us our 0.875. All right, so your calculator has 2 binomial distribution functions. So Binomcdf, you use that when you're looking for a probability of exactly k successes, like exactly 2. Binomcdf finds the probability of k or fewer successes, so x less than or equal to k, and then it will take care of adding up all the probabilities until you get to k. All right, so let's try one other than the coins here. So suppose that 24% of residents support the funding of a new city park, and we pick 10 residents at random. X will be the number of residents in that sample who support the funding. All right, so this will be a binomial experiment, and our n would be 10. We're going to talk to 10 people. Lowercase p, the probability of a success. So they say 24% support the funding, so that will be 0.24. And now Q then would be the probability of a failure. So the probability they do not support funding the new city park. So Q will be the complement of P. So Q is always 1 minus P. So 1 minus 0.24, that will be 0.76. So if 24% of residents support the funding, 76% of residents do not. Now, we're not going to need the Q right now, but we will later. So just good to keep what the P and the Q are in mind. All right, so now let's do part A. So find the probability that exactly 3 support the funding. So what I did here was just list all the possibilities for X. So maybe none of the 10 support the funding, or maybe just 1 person out of 10, or 2 people out of 10 support the funding. In this question, we're looking for the probability that 3. So I'm just going to circle that 1 value. And I have a graph of the distribution here shown. So the 3 there, we're looking for basically the area of that particular bar. So we think of probability in terms of the area. So if we were to add all the probabilities together, we would get 1, because one of those things is guaranteed to happen. But we're looking for just this probability. So it's the probability that X equals 3. All right, so if it's an exactly a value case, then this is when we do Binomcdf, back to the original probability distribution function. All right, so we need n, 10, p, 0.24, and then that value of k. All right, so I'm just going to clear my screen here, and I'm going to continue scrolling. There's quicker ways to get there, but I'm going to go Binomcdf, and then 10, comma, 0.24, comma 3. And at the top, I said round to at least 4 places. We'll just do 4 decimal places. So that's going to be 0.2429. And I just feel like writing it as a percent as well, so I can speak it. There's a 24.29% chance that 3 out of 10 people will say that they support the funding. All right, so whether it's decimal or percent, that represents the area of that single bar. Okay, so let's compare that to B. Find the probability that at most 3 support the funding. So at most 3 means 3 or fewer. Remember, at most means at the max. So 3 or fewer. All right, so we could do binomial PDF for each one separately and then add those probabilities, or the quicker way here is to say that if we want the number of successes X to be at most 3, that's less than or equal to 3, the calculator can add the probabilities for us if we use our binomial CDF, so cumulative function, and then N, P, and K. All right, and you'll see a little bit more later why I'm referring to this value as K, so we can write some formulas. So as I did up here, so when it's X less than or equal to a number K, in this case, K is 3. All right, so let's see what happens there. So I'm back to my distributions, this time binomial CDF, and then 10, comma, 0.24, comma 3. And we're getting a bigger probability because we're finding now not just the probability of this single bar at X equals 3, but all of those 4 bars that we see there. So for those 4 probabilities added together, that's coming out to be 0.7988, or in decimal, I'm sorry, or in percent, 79.88%. So that would be the areas of all 4 of those bars. All right, so before I leave this example, I just want to point out here that this graph is skewed to the right, So more of the probability is at this lower end of the possible set of values. So because the probability of a success was less than 50%, more of the probabilities will be down here with those lower values. So just kind of wanted to point that out as kind of a comparison as we move forward. All right, so those are our 2 functions. So those are the only 2 the calculator has. So those can handle the exact case, binomial PDF, and the K or fewer case. And then we have to use binomial CDF. And then we have to learn how to handle some other inequalities as well. And we do that next.